So, Jai Hind to all of you. Today we are going to cover a very important topic of digital system design, that is K-map up to 5 and 6 variables. In this PPT, we will cover about the K-map, then different types of K-map, that is 2 variables, 3 variables and up to 6 variables K-map. First of all, what is a K-map? K-map is basically a minimization technique which is used to minimize basic Boolean expression. We can use basic Boolean laws to minimize Boolean expression as well, but those techniques are not universal, not standard, as well as varies from person to person. So basically, K-map is designed by Maurice Karnaugh, and it is a map method used for synthesis of combinational logic circuits. It provides simple, straightforward procedure for minimization of Boolean function, which is also called as a pictorial representation of truth table. It displays the minterm or maxterm expression in a geometrical pattern wherein all the binary combinations are included in K-map. It is a diagram basically made of squares and in the form of a matrix. The final expression comes in terms of minterm, that is SOP, or maxterm form. First of all, the step to design a K-map requires to find out the number of variables in the Boolean expression. So, if there are 2 binary variables, then the Boolean expression, then the K-map consists of 2 to the power 2, that is 4 cells. Similarly, if there are 3 binary variables in combinational equation, then Boolean expression K-map consists of 2 to the power 3, that is 8 terms, and similarly this goes on till if the Boolean expression consists of 6 variables, then 2 to the power 6, that is 64 cells in K-map. So, first of all, construct the K-map as per discussion based on the number of variables in Boolean expression. Then examine the map of squares and form the group. The group consists of the number of ones which can be in the form of 8, 4 or 2. A group of 8 ones is called as octet, a group of 4 ones is called as quad, and a group of 2 ones is called as pair. So, once we input the number of ones in K-map, then the next step is to group the number of ones in terms of 8, 4 or 2, and the priority is given to the largest size group, that is first of all we search for octet in K-map. If there is no octet, then we go for quad, and if there is no quad, then we search for pair. By forming these pairs, we usually minimize the number of variables in the final Boolean expression. Using logic adjacency theorem, we can conclude that a group of 2 squares eliminate 1 variable. Similarly, a group of 4 squares eliminate 2 variables, and a group of 8 squares eliminate 3 variables, and so on. For example, this is the smallest size of K-map of 2 variables. As we know that the 2 variables consist of 4 combinations. If we take the input as A and B, then the input combinations are 0, 0, 0, 1, 1, 0 and 1, 1. These terms are expressed in K-map in the form of 2 by 2 square, that is consists of 4 cells in K-map. One variable is taken in the left side and the other variable is taken in the top side, that is A bar A and B bar B. We can easily see from this expression that A variable consists of 2 terms A bar and A. Similarly, B variable consists of 2 terms B bar and B. So, the first Boolean term is called as A bar B bar. The second Boolean term is A bar B. This. Third Boolean term is A B bar and the next is A B. In this order, we can input the number of terms within K-map in terms of SOP or POS form. I am hereby discussing the min term, that is SOP form of expression. So we can take a simple example of a two variable K-map. Herein I have taken an SOP form of expression which consists of two min terms, that is 2 and 3. So we can input the value in the K-map 2 and 3. 2 is called as A B bar, we have taken it as 1, and 3 is 1 1 A B, we have taken as 1. So the resultant K-map consists of one pair of 1 and 1. When we take a pair, then B and B bar both are included in the expression, which will be nullified, and the resultant expression will be A. We will see one more example of min term, that is consisting of 1, 2 and 3. So the two inputs are 0 0 0 1 1 0 1 1, and the min term, that is 1 2 3 is 1. We can input these terms in the K-map in form A bar B is 1, A B bar 1 and A B 1. So two pairs are formed in this K-map, we can see from this expression, and the resultant expression will be A plus B. So hereby we can see that a simple two variable K-map can be easily solved, and we can easily find out the min term expression using K-map. If we talk about a three variable K-map, then it consists of 2 to the power 3, that is 8 cells within K-map, and this value goes from 0 to 7. For three binary inputs A, B, C, the min term goes from 0 0 0, then 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. The first term is called as Y0 or min term 0, which can be written as A bar, B bar, C bar. Y1 term can be written as A bar, B bar, C. Second term can be written as A bar, B, C bar. Third term M3 can be written as A bar, B, C. M4 can be written as A, B bar, C bar. M5, that is A, B bar, C. M6, that is A, B, C bar, and M7, that is A, B, C. So we can easily input these terms within K-map, as we can take one input on left side and the two on top side, or vice versa. We can also draw this K-map in vertical form, like we can take two inputs on the left side and one on the top. Both these type of K-maps give the same answer. Herein we take the combination A, B on left and C on the top. So we can easily input these values based on the combination 0, 1, 2, 3, 4, 5, 6, 7. Then form the octet, quad or pair and solve the resultant expression. So this is a simple SOP form of three variable equation. We will take an example of SOP equation consisting of term 2, 4, 5, 6 and 7. These terms will be entered within the three variable K-map as 1 and the remaining term will be left 0. Then the product terms are grouped. First of all we search for octet, then quad, then pair, and the resultant expression is find out. So as we are seeing that the largest term is 7, so it is a three variable expression. We can form the truth table A, B, C and put the values 2, 4, 5, 6, 7 as 1 and the remaining as 0. Then these values can be entered within K-map simply A and B on the left side and C on the top side. 0, 1, 2 is 1, then 4, 5, 6 and 7 are 1. As we can see from this K-map, there is no group of 8 ones is there. So no octet is formed. Then we search for quad. One quad is there and one pair is there. One quad and one pair. When we search for quad, From the left side, B and B bar both terms are coming, so it will be cancelled out, and A. And from the top, C and C bar both will be cancelled out, so only A. And for pair, A bar and A will be cancelled out, that is B, and from top side, C bar. So the resultant expression will be A plus BC bar. Now moving towards the next K-map, that is 4 variable K-map. A 4 variable K-map consists of 2 to the power 4, that is 16 binary combinations from 0, 0, 0, 0 to 1, 1, 1, 1. Or if we write in terms of min term, that is from 0 to 15. So we take one example here of 4 variable K-map where the input variables are A, B, C, D, and the min term expression given here is 0, 1, 2, 6, 8, 10, 13 and 14. These values are taken as 1 and the remaining as 0. So in this we can enter the values in K-map. Again take 2 variables on the left side and 2 on the top side. Then group them in terms of 0, 1, 2, 3 is 0, 4, 5, 6 is given as 1, 7 is 0. Then 8 is 1, 9, 10 is 1, 11 is not given, 12, 13 is 1, 14 is 1 and 15. So these terms are given here and we have input these min terms in K-map. The min term expression which are 1 is entered as 1 in K-map and remaining are left blank. Now we can see from this K-map that there is no group of 8 ones, hence no octet is formed, and next we search for quad. There is no direct group of 4 ones here, but we can see that there are 4 ones at the corner which forms a quad. We can take this as a piece of paper, and when the piece of paper is folded, the 4 corners, folded 2 times, the 4 corners come one over the other which forms a quad. So we take direct groups, we fold the paper vertically and take top or left side groups as well. So there is one quad, one pair and a single one. For quad, we can see that A bar and A will be cancelled out, so B bar, and from top C bar and C cancelled out, that is D bar. So for quad, the equation will be B bar D bar. For pair, from left side we see that A bar B bar, and from top side we see that C bar D will be cancelled out. And for single one, both the terms from left and top will be taken as, that is A, B, C bar, D. So this is the resultant expression of given min term form. We also consider don't care terms in K-map. What is a don't care term? Don't care term is basically the combination of inputs which are not used in the given circuit. For example, if we are using BCD, that is binary coded decimal input, as BCD requires 4 binary inputs but consists of only 0 to 9 combinations. So the 10 to 15 combinations are don't care terms because it will not affect the output. So in any binary circuit, if there is certain number of binary input combinations which are not used in output, these combinations are called as don't care terms. And will it affect the output of K-map? Yes. Don't care terms are not considered 0 or 1. Rather, they are written as cross in K-map, and if required or if it aids in the grouping, then we consider don't care as 1. Otherwise, we left it and consider it as 0. So don't care term can be considered as 1 or 0 if it is required to group number of ones to form a larger group, then it will be considered as 1, otherwise it will be considered as 0. So, first of all we will take one expression of minterm of 4 binary variables, where the minterm are given as 1, 3, 5, 7, 9 and the don't care terms are given 10 to 15. So, we will input these values and 4 variable K-map. 1, 3, 5, 7 and 9 are taken as 1 and 10 to 15 are taken as 0. Now, we will see that these 4 ones will form a quad if we don't consider don't care terms. But if we consider don't care term, then it will form a octet. And we have already discussed previously that the higher size group is preferred in K-map. So, octet is preferred over quad. So, we will not use this combination, but we will take the help of these don't care terms and form a octet. So, the resultant expression will be A bar and A will be cancelled out, B bar and B will be cancelled out, and the output expression Y will be become equal to D. So, don't care terms are very important in K-map. Those input combinations which are actually not used in K-map are not used in binary equation will work as don't care in K-map, and don't care is not equal to 0 or 1, rather it will, if it helps in forming a larger group in K-map with ones, then it will be considered as 1, otherwise it will be considered as 0. We will take one expression of POS form as well. What is POS form? That is product of some form. It is called as max term representation. It is basically a dual of minterm expression, that is in K-map A means 0 and A bar means 1, and max term is represented by pi and capital M. So, given a 3 variable POS equation 2, 4, 5, 6, 7 in minterm, then the remaining terms are max term, that is 0, 1, 3. So, if we consider the given Boolean expression, then 0, 1 and 3 are the max term and remaining 2, 4, 5, 6, 7 are the min terms. So, we can group the equation in terms of max as well as min. As the 1 is entered into K-map in terms of min term, 0 is entered in K-map if we solve for POX expression. So, 0 for 0, 1, 0 for 1 and 0 for 3, and we group zeros in POS form. In POS form, 0, 0 is written as A plus B, 0, 1 is written as A plus B bar, 1, 1 is written as A bar plus B bar, and 1, 0 is written as A bar plus B, because 1 means bar and 0 means literal, and the dot is replaced by plus. Similarly, on the top side, this is C and this is C bar. So, for this expression, we can write it as A plus B, and for this vertical pair, we write it as B and B bar cancelled, that is A plus C bar. So, this is the POS form of given Boolean expression. If we convert it into SOP, like if we want to solve it in terms of SOP form, we can easily solve it by entering 1 and grouping it. It will form a quad and a pair, and the expression will be quad and a pair, and the resultant expression will be A plus B C bar. So, in SOP form we solve by grouping the number of ones in key map, and in SOP form, that is mean term form, A means 1 and A bar means 0. POS is just the dual of SOP, wherein A means 0 and A bar means 1, and we solve by grouping the zeros in terms of max term in K map and write the expression in product of sum form, POS form. We will take one more example of POS 4 variable K map. The max term 0, 2, 4, 6, 8 will be entered as 0, 0, 2, 4, 6 and 8 will be entered as 0, and 10 to 15 will be entered as don't care. Again here we will group for zeros, and when we take the help of this cross, one octet is formed by folding from the two extreme columns. So we can see easily that the D will be the output. So to solve POS form, again we will consider A as 0 and A bar as 1, and POS is just the dual of SOP form. Herein we cover all the zeros, and the don't care is considered 0 whenever it is used for grouping, else it will be considered as 1. Now moving towards the very important K map, that is 5 variable K map. The largest size of a single K map is up to 4 variables, because as we increase the size of K map, the complexity increases as 2 to the power n, because for a n variable K map, the number of cells in K map is 2 to the power n. So if we make a single 5 variable K map, then it consists of 2 to the power 32 cells, which is quite difficult to handle. So the largest single K map is up to 4 variables, and we use two 4 variable K maps to form a 5 variable K map, that is 2 into 2 to the power 4. Herein, if we consider 5 variables A, B, C, D, E, then the MSB, most significant bit, is taken outside, and the remaining 4 variables are taken within K map. For A equal to 0, 0 to 15 combinations are taken, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And for A equal to 1, next 16 combinations, that is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 will be taken. So 5 variable K map is very important, and we have to just make an important note here that the MSB is always taken outside. If we take any other variable, then the whole combination will get changed. So we always take the MSB outside. Prepare 2 K maps, one for 0 MSB, another for 1 MSB. For 0 MSB, we take 0 to 15 combinations, and for an MSB, we take 16 to 31 combinations. And we group the terms as per previous methods, that is octet, quad and pair. One more grouping will also be there, that is when 2 K maps are one over the other, one on the top of other. Then if the group of ones are at the same place, then also they will form a group. We will take one example for this. Consider a 5 variable K map A, B, C, D, E. So we make 2 4 variable K maps and fill the term 0 to 15 in first and 16 to 31 in second. First one is corresponding to A equal to 0 and second corresponds to A equal to 1. So first of all, we input the term 0, 1, 2, 3, 4, 5, 6, 7. then 8, 9, 10, 11. These terms are in first K-map. Then 16, 17, 18, 19 are not there, 20, 21, 23, 24, 25, 26, 27, 29 and 31. These values are entered within the K-map. So now we can see from these two K-maps that certain number of ones are overlapped at same position in these two K-maps. Like these 4 ones and these 4 ones are at same position and they will form a octet. 4 1 on the top of 4 1 will form a octet. And if a group is formed with both the K-map, then A bar and A both will be in the equation and will be cancelled out. That is, A bar and A both will not be there in the final equation. One more quad is there. One quad is there. Now we see that this one and this one, or this one and this one, we can form a pair of 2 ones. So this one is a pair, then this one is also a pair, and this is a single one. So here one octet is there, one quad is there, and 1, 2. 2 pairs are there and one single. There are 5 groups, 1 octet, 1 quad. This one and this one form a pair, and these 2 ones will form another pair, so 2 pair and a single one. These are the final terms within this 5 variable K-map, and we can easily find out the equation. For this octet, we can see that A bar and A both will be cancelled out, so the final term will be, for octet, the final term will be B, C bar, all the top terms will be cancelled out. Okay. For this quad, the term will be A from outward variable, B, and from the top E. For pair, we can see that this one and this one comes from A bar and A, so will be cancelled out, and we can see that it is B bar, C bar, D bar, E bar. And for this pair, it will be A bar, B bar, D bar and E bar. So this term, and the last, that is single one, the term will be A bar, B bar, C, D, E. So this is the final term, that is consists of 1, 2, 3, 4 and 5 terms in this K-map. So the final equation for this K-map will come out to be B, C bar plus A, B, E plus B bar, C bar, D bar, E bar plus A bar, B bar, D bar, E bar plus A bar, B bar, C, D, E. I hope the solution is clear to all of you. Now, there is one more example of this K-map, and I think we can easily solve this K-map by just inputting 0, then 5, 6, 8, 9, 10, 11, 16, 20, 24, 25, 26, 27. Again these 4 and these 4 will form a octet. This will form a pair. These 2 ones will form one more pair, and this will form this one, and this one are single ones. This will not make any group. So there are 1 octet, 1 pair, 2 pair and 2 single ones. So we can easily find out the equation of these variables, and I will leave it to you all to solve this expression. Now moving towards 6 variable K map, 2 to the power 6, we form 4 into 2 to the power 4, that is 4 variable K map, and we take the MSB 2 variables outward, and for 0 0 first, for 0 1 second, for 1 0 third and for 1 1 fourth K map. The variables terms will move from 0 to 15, then 16 to 31, then 32 to 47, and then last 48 to 63. 0 to 15 in first, 16 to 31 in second, 32 to 47 in third, and 48 to 63 in last. We can take an example. These terms are there. So for A bar, B bar 0 0, 0, 4, 8, 12, then 26, 27, 30, 30, 1, then 32, 36, 40, 44, and 62, 63, 40 and 44. We can group these terms. There is 1 octet and 1 more octet. So herein we will group again in the same manner. Just one more thing, that we can group the multiple K maps either in horizontal fashion or in vertical fashion, but never diagonally. We will never group it in diagonally. We will group in vertical or horizontal. Or if a particular one is in all the 4 K map, then also it will consider as a group. So the resultant expression as per this K map will be A bar and A will be cancelled out, that is B bar, and for these K map it will be E bar and F bar, plus for these two duo, A 0 1 cancelled out, that is B, and for these two it is E, and from this side C. So this will be the resultant expression by using these combinations. Moving towards the next. Thank you. So I have covered in this video various K maps and to describe the solution of Boolean expression minimization using K map up to 6 variables. Thank you.